So I'm just going to tell you what a squared is. Turns out to be 0, negative 9, 0, 0, 1, 0, and 0, negative 2, 0. Notice that this matrix did not get zeroed out. So we're going to choose W1. We want W1 to survive this matrix, but not survive this matrix. And there's lots of right answers, and I'm going to have to check every single one of them, just like I did on this homework. Anybody have a good choice?
1, 0, 0.
Excuse me, 1, 0, 0 sounds great. Because when I calculate W2, which is AW1, okay, when you write multiply by 1, 0, 0, all you do is pick off the first column here, which is going to be, oops, a column, that right there. The thing that you get right here has to be an eigenvector. So you can check your work. It's a good check. Did you get an eigenvector? Well, what was our eigenvector for lambda equals 0? Oh, it's right here. So is that an eigenvector? It is, because it's a multiple of an eigenvector. Can I change this to the eigenvector? Can I change W2 to just be 2, 0, 1, or do I have to leave it as negative 2, 0, negative 1?
Change it.
Very important, you cannot change it. This W2 is required to be whatever A times W1 is. You can't change it back. I mean, the only thing you could have done is if you had chosen W1 to be that, now you would have changed these signs and it would have been that W2 is equal to V. But that should not be your concern. Your concern is not, you're not trying to choose W1 so that it gives you V. That's not important. You're just choosing W1 so that it survives A times W1. So that it survives A. So that's fine. And then if you apply, so you have two choices. Once you get this vector, you can either apply that vector to A again, or you can go back to the original thing that you chose and make sure that A squared kills it. 2 steps, it's got to die. So you can see that that will happen here. Okay? So x3, we're ready for the answer. x3, there is no e to the lambda t. All we have is w1, 0, 0, plus t times w2, which is negative 2, 0, negative 1. That guy right there. All right? Oh, are we done yet?
No, write the general solution.
Right, we need to write down the general solution. We have all the pieces. Guys, when you're taking the test, circle your pieces as you go. If you circle them, then you'll have no trouble finding them when you need them. Circle, circle, circle. So now I could just go write down the answer, which is x of t equals. By the way, you could just say c1x1 plus c2x2 plus c3x3, where x1, x2, and x3 are above. You could just do that. Is there any reason here why I might not want to just do that?
Initial condition.
Right, we have a little extra work to do, which I haven't gotten to yet. So there's a little extra work to do. So I'm actually going to put in what we have. So c1 e to the negative t, 9, negative 1, 2, plus c2 times 2, 0, 1, plus c3 times, now it's going to be c3 times 1, 0, 0, plus t times negative 2, 0, negative 1. Okay? And so that's the general solution. Now if we put in 0 for t, then we know what we should get, because that was an initial condition. What does does the initial condition allow you to do? Right. It allows you to solve for the constants. So if I put in x of 0, I'm going to get C1 times 9, negative 1, 2, plus C2 times 2, 0, 1, plus C3 times 1, 0, 0. All of the t's are 0. Get that? And this should equal negative 2, 1, 1. It's a linear system. So I keep saying this material all comes back together. This goes back to chapter 2. Basically, there are 3 equations here, right? I'm not going to put it into a matrix and solve it. All I'm going to do, you can actually do this one kind of quickly, because if you look at the middle slot, right, C1 has to be negative 1, right? Because negative of C1 has to equal 1. And then the bottom slot, 2C1 plus C2 has to add up to 1. If C1 is negative 1, then what's C2 equal to? 3? Yeah, 3, that's what I got. All right, and then you can solve for C3 from the first line. Let me just say let's see, what did I get? I got 1. I got 1. Just check it on your own. Okay? Then what you should do is you should go back and write down your final answer again. So, because this thing right here, this is the general solution. That's the general solution. But now we have a particular specific solution that satisfies my initial conditions. Okay, so final answer would be x of t equals negative e to the negative t times 9, negative 1, 2 plus 3 times 2, 0, 1 plus 1, 0, 0 plus t times negative 2, 0, negative 1. Guys, there's no reason why you have to clean that up any further. Just leave it. Why risk making a mistake, you know? Just leave it kind of like that. I think it's fine. In my solution, I put it all together. That's just because I wanted to do that. I'm not saying you have to do that. Okay? This is actually fine. Yeah. So even though in my solutions I did compress it into a single vector, there's lots of ways to write many of these answers. So that would be fine. Okay, so we've done kind of the phase portraits, we've done the defective. Now there's another defective case, right, where you have a W 3, 4, and 5. Right? I don't really feel like doing one of those right now. We did a couple of them already just within the past 4 or 5 days, so, and they're in the homework that you just got back. So I think I will leave that out. I just want to see. Yeah.
Are you by any chance going to give us like a formula sheet at all? Or do we just have to memorize like the couple formulas that we use?
What I'm going to give you is a table of annihilators and a table of integrals.
Okay.
The same thing I gave you for the quiz.
Okay.
Nothing more than that.
Okay.
Yeah. You have to know all the other stuff. There's not that many.
Yeah, there's only like a couple, but I just wanted
Just a couple, yeah. Okay, we did a couple of those. I haven't done all of those on problem 6. I have all of these higher order differential equations you can solve. I haven't really done all of those, but I feel pretty good. I haven't done, I don't know, I'm just kind of running out of steam as part of the problem.
I think we all are.
Yeah, it's kind of warm in here. We're a little tired. I tell you what, the complex numbers, when you have the roots that are complex, of course, that will not be a defective case, but you do need to make sure you know the Euler formula and how to FOIL it out and extract those two real solutions out of it. So that's, a lot of that is in section 7.4, and I don't have those papers to get back yet. Problem 3 is a good example of it on the review sheet, but I'm kind of feeling like maybe I want to quit for the day. Would that be reasonable?
Yeah.
Why don't we do that? If you go through any more of these and you're either not following it in my solutions or you just want to talk it through with me, I would be more than happy to kind of sit down with you with my soft voice, one-on-one, and kind of go over it. Does that sound like a fair way to go about it? Why don't we do that? What I think I'm going to do now is give myself a little break, and then I am going to be in my office this evening for a while. I may put a note on the door saying please knock, so don't be shy to knock, because I might take a little nap, thrust up a little bit, see if I can shake this thing. But I think we've done pretty well covering this stuff. Just a little bit on the complex numbers that you need to review. Yeah, Kevin?
As far as formulas, do you recommend we should know the 2x2 determinant of the inverse to solve for one of those diagonalizable?
Yeah. That's true. We didn't really do an example of that today either, did we? This thing?
Yeah. Do you recommend we should know the...
Yeah, you should always know the formula for the inverse of a 2x2 matrix. I'm kind of expecting that people do know that. All it is, I'll just do it. 1 over the determinant, swap the diagonal numbers, and change the sign on the other two. Should just know that cold. Know it for the next 2 exams cold. That's just really helpful if you know that. Really quickly here, do people remember this part? Because I didn't go over this either. Not every matrix A has an equation like that, only the diagonalizable ones. Okay? But the idea is that the matrix S has these eigenvectors in its columns. So just remember that. And if the matrix is diagonalizable, it has n linearly independent eigenvectors. Right? So it means you can build this matrix. If the matrix is defective, you can't come up with this. You can't do it. Right? And then there's the D. Well, I asked this on the quiz. Yeah. The biggest problem with this usually is getting all those lambdas right, finding all those V's correctly, but the diagonal matrix has eigenvalues that correspond with the eigenvectors here. Okay? Don't worry, I think I did one example where I showed students switching from Professor A to Professor B's section or something.
Yeah.
I did that in class. I'm not going to ask you one of those, just because we didn't do that in the homework, and it's really not something I emphasized enough. The main reason I showed you that example was I was trying to convince you that diagonalizable matrices are important, and they have applications. So as long as you just smile and say you believe it, and that those applications are there, then I'm good with that for now. But you should be able to do this part right here. Yeah, Cal?
One last question.
Sure.
For the admission review information packet, for number 12, when it talks about Romeo and Juliet, is that something we have to...
That's the same as
That's what he
the
was just saying.
switching classes,
Yeah.
right?
Yeah. Is that similar to...
Well, the switching classes one was not a differential equation. This is talking about this is a differential equation. Might be all right to take a look at that.
Okay.
Yeah, just to make sure. Basically, it's the thing about that one is that it's really a system of differential equations, so you can view it as a linear system. It's just that you have constants in that system, but it's just a 2x2 system. There's two unknown functions. Juliet's love for Romeo and Romeo's love for Juliet. So those are the two unknown functions, and you have the derivatives of both of those. You can build a 2x2 matrix and put the unknown functions there and then just solve it from there. So it is a word problem. It's putting a linear system into a word problem. So the examples that I did of that in class were, I talked about connecting tanks of chemicals together or spring mass systems together. I didn't talk about a love-hate relationship being modeled this way. So I was just trying to have a little fun with it. It's the same kind of thing though. Just take a look at it. Don't sweat it too much though. We didn't really do any homework on where I didn't give you any problems where you had to take a whole paragraph of words and put it into a problem that looks familiar. So let me just say this. The more time I spent on something in class, the more homework we had, the more group work we had, whatever things we spent the most time on, those are the things that are going to be worth the most points. I'm not saying that I won't ask you something that you've never quite seen before. I'm actually comfortable doing that. I'm not going to make a whole test like that. But I might ask you one or two things to just see, does this person have a mastery enough to take what they've learned and be able to solve a slightly different looking problem to what they saw before. But it's kind of hard for you guys to just go looking for a needle in the haystack. Like, well, I wonder what strange question he might ask. So your best bet is to focus on the mainstream stuff and knowing it well. Not just being able to go through the motions of it without your brain working, but to actually understand what you're doing. If you can do those things, then whatever problem I might give you that's a little different than something you saw before, I'm not trying to throw something at you that isn't fair or that it requires you to completely get creative. I'm basically going to try to ask you something that sees how much of the concept of the material you actually understand. So this would be an example of that. A word problem of the order of problem 12. It's probably on the harder side. You're not going to see a test full of questions like that. But it wouldn't hurt to just kind of look at it, at least to get the spirit of kind of what kind of things I might do.
Gotcha. Okay.
But, yeah. So yeah, I think, there's a lot of problems in here. Problem 11 in the review packet is a good one. It's actually a non-homogeneous linear system. So we haven't talked about that yet. That's actually the lecture on Wednesday. But I said verify that something is a particular solution. So I gave you the solution. On Wednesday I'm going to show you how you get that solution for yourself. Right now we don't know how to do it, but I can still ask you about it and say, here it is. Check that it works. Well, you haven't quite done a homework problem like that before. But if you understand what it means to check that something is a solution to a linear system, well, you'll be able to do it. So your goal is really to try to really understand everything well, not just be able to superficially go through the motion. Okay? So, is everybody doing pretty well with the complex numbers? The ones where you have to FOIL them out. Take the first and last and put those together, then the outers and inners and put those together. Yeah, that's almost more on the procedural side, and we just didn't do it tonight because I just didn't have the energy, I guess you could say. Other questions? So those little tips on the product of the eigenvalues being the determinant and the sum of the eigenvalues being the trace. If you are struggling to get your lambdas, which seems to be the biggest problem, take advantage of that. It might help you. I guess we didn't do an example where we actually solved for the constants in the annihilator method either, but that's just that's just taking derivatives and setting setting one side equal to another. I think there's plenty of those that you can look at. Yeah, I think there's plenty for you to do, even if I don't have a voice, you still have plenty to look at and get ready for Monday. Good thing about this for me is I don't have to talk on Monday as much. Maybe by then I'll feel better, hopefully. So, I feel kind of bad. I don't want to like quit if people do want to ask me some more things. Everybody okay with that? Maybe, maybe tomorrow I'll feel better and you guys, or even later tonight after I just give myself a break, maybe then you might want to ask me some more questions, okay? Thanks for being understanding about it.
Thank you.
Darn smoke.
Yeah.